This is Java programming, and my name's David Hayes. And we're first going to go over some of the material in Blackboard, then we'll get to some of the software and writing code and so forth. Just as general, I always mute everybody to begin with in Zoom. If you have a question to ask, you unmute yourself. There's a couple different ways you can do that. You can put your mouse at the top, bottom, and have that bar pop up, and you'll see the mute option. The second way is if you just simply hold down your space bar while you're talking, then that unmutes you. Then when you let off the space bar, then you'll be muted again. Okay, here's the syllabus over here on the left-hand side. Under information, here's my phone number, and here's my email address. Textbooks, the OCA study guide, available in the bookstore, or buy it online, rent it, whatever. And think Java, which is free. So we'll see a link for that. Objectives, basically learn Java. Grades, projects, tests is 80%. I say tests here. Really, for this course, you only have one test. It's a programming test. It's not intense. It's just nothing to stress about. It's got 3 questions on it. It's part of the Higher Learning Commission for accreditation purposes requires us to assess our program learning outcomes. And so I had to decide that myself. What do I want people to know coming out of programming? And well, I want to know the if else, the while, and the for structures. So again, 3 simple programming projects that you'll be assigned, and then you'll put your code in and the answer. So just one test. Lots of projects, and then the final project. Here's the schedule. This first week is Think Java Chapter 1, getting our software installed and everything. Now, if I click the course content here, here's the Zoom live session. I get on every Friday from 9:30 to 10:30 and cover material. I record it in YouTube video format. So if you can't attend class, no big deal. It's recorded, and I'll put the links under the unit folders down here. So like today, after I get done recording this session, then I'll put it down here in the unit 1. Here's the free ebook, Think Java ebook. So software install. I was actually considering showing this in class today, but it didn't work out quite like I intended. This one right here, the Java SE Development Kit. If I click that, then you scroll down. Depending upon your system type, for mine, I got Windows 64, then I would use this one. When I tried to sign into that this morning, it told me Oracle was down. So I would hold off trying to install it. I wouldn't try to do it this morning. I don't know how long it'll be down. This is the, as it indicates, the development kit for Java. You could actually write your Java programs with Notepad. You wouldn't even need an editor. We're going to make our lives easier. We're going to use an editor. But this is kind of the meat of the development. And close that. The second one here, the Java Netbeans 12. Now I did, since on my other laptop I couldn't put the development kit on there. I knew I couldn't show it, so I went back to my old laptop, and but I updated to the new version of Netbeans. This does not require a sign-on into Oracle, so you can go ahead and do that. Well, I'd probably do Java first. But But you see down here, Java Netbeans 12 feature update 1. Then you click the download here. Lots of different information on here. The one I ran was this one right here. Now, let's see, different deployment platforms. Okay, this one's Mac, and then Linux. Now, if you have any trouble getting that set up on a Mac, I never have set up on a Mac. Then let me know. So I got a MacBook I can test it on. Okay, under course content, down in Unit 1 folder. I have a project here, but I'll put a second project. I'll also upload assuming we get to the second project, I'll also upload the PowerPoint and the YouTube video here that I'll create. Is there any questions on the Blackboard piece? Okay, after you get it installed, if you come down here in the search bar and you type Netbeans, I got 2 versions on this computer, but I'm gonna go into Netbeans IDE 12.2. This is what Netbeans looks like, and we're gonna come back to this, but this is if you installed it, then this is what you should be seeing. Okay, Java Programming, Chapter 1, How to Think Java. Now, programming languages, there's something called high-level languages, C, C++, C#, Python, Ruby, JavaScript, Java. There's also a low-level language called machine language. Computers have their own language that they use to run programs, to handle the hardware, and so forth. And some of it's a pretty low level. It's hard to program. High-level languages were developed to simplify the process so that we could fairly easily write a computer program. In theory, you've heard that computers talk via ones and zeros. That's not quite true. The 1 indicates a certain level of voltage, 0 indicates a certain lower level of voltage. And you could try to program voltage going across, but that'd be impossible. You could try to do the machine language. And I'm not even sure if I've ever seen what machine language looks like, because nobody ever programs in it. We work with nice languages like those ones listed. Now here's the advantages. For the high-level language, it's easier to program in. The programs take less time to write, they're short and easier to read, and they're more likely to be correct. High-level languages are portable, meaning they can run on different kinds of computers with few or no modifications. Low-level programs can only run on one kind of computer, have to be rewritten to run on another. I think I was taking a look at VHDL for another class, and I was trying to find software that you could run off the cloud, so you wouldn't have to install anything. And I found some online editors, online packages where you could edit it and then run it, and they wouldn't run the VHDL that we have in our book. So it's just like, oh, that's nice. It's very hardware specific. So the VHDL that's in our book is not the same VHDL that's on that site. That's frustrating. Because I'm sitting there, how in the world am I going to find if I do have anybody that's using a Chromebook and Introduction to Digital Design, how am I going to find one without just going and trying all site after site? And well, this higher level languages, you write a program in C, and then if you want to run it on something else, you take that program, you email it to yourself on your Linux, and then recompile it, and you're up and running. So that's the beauty of that portability. Now, interpreter, how that works is you take your source code, the program you write, and it comes in an interpreter, and line by line goes through and runs it, and then it has the output go here. Now that's going to be different than how compiled languages are ran. Compiled languages create an executable that you then run, so it doesn't go line by line. See, it says process the program little at a time, ultimately reading lines, performing computations. Compiler reads the entire program, translates it completely before the program starts running. So everything has to be perfect to begin with, no errors or anything. And then after you got it compiled, you can run it, and it's usually quicker. Compiled languages produce programs that run faster, but they have their own disadvantages. Now, Java is both compiled and interpreted, so it's kind of unique in that way. Instead of translating programs directly into machine language, Java compiler generates bytecode. Similar to machine language, bytecode is easy and fast to interpret, but it's also portable. So it's possible to compile a Java program on one machine, transfer the bytecode to another machine, and run the bytecode on the other machine. The interpreter that runs the bytecode is called a Java virtual machine. Let's see. Okay, so this is the Java. Now, this is not the development kit. This is not what you use to write Java programs. This is not Netbeans. These are the software that you want to put on the individual machines, such that if I give you a Java program, you could run it. So this gets installed on the computer, and then this part right here, where you have your bytecode. This is the part that software on the computer runs. So you got Max, Linux, Solaris, so forth. These are all, you can think of them as players. It's not quite like that, but you think of it as a player. It will, it's a program on those particular machines that then runs your code. So now that doesn't sound like much when I explain it, but that was very important. Um, when I first started working at Koch Industries, we programmed on a Unisys mainframe. And at some point in time, they wanted to go away from the Unisys mainframe. Mainframes cost millions of dollars. They're huge machines, just a huge huge job in keeping them up. So they're just not very practical. But they could not easily take all their programs and put it on a different platform. It just wouldn't work. So it was a challenge. So having code that you run on one platform that if you get rid of and you can run it on a new platform is very, very beneficial. Some places are still running mainframes. Let's see here. 251 jobs out there for mainframes. Um, why are they doing this? Mainframes are this antiquated thing from the 50s and 60s. They started going out in the 80s. So why are they still doing it? Well, when you put such an effort into all of your systems being on the mainframe, um, you got 20 years of programming code that's been written. Well, assuming those systems are needed, if it took you 20 years the first time to write them, well, it might take you less time, but you're still talking maybe 12 years to rewrite them all into something that would run on like a server or a Linux machine of some sort. So it's not an easy task. You can't just take it and copy it and run it on that other one. You have to redo it. So that's why you got people still using mainframes. It's not because they want to, um, but they have to. Unisys mainframes probably about 10, but I don't know. 7+ years. I used to program in a Unisys mainframe. I better apply. 3A soft. Not the Unisys I worked with. Boy, they're looking for somebody with a lot of experience. That wouldn't even apply for me. I worked, I guess, 3 years with mainframe. So I wouldn't have 84 months. Here's the idea. You write your code. Then you got your compiler that gives you your bytecode. Now, you see this right here, it says Java C, hello Java. This is if you're using that development kit alone. You're not using the nice Netbeans we're going to use. That's how you type it. You go to your command prompt, you come down here, you do cmd, you have to be in the right directory, and you type Java C test Java. I'm not in the right directory, but that's what they're referring to. Then that creates this file called hello class. Then at that point, this, in theory, you can take this hello.class and transfer it to a different platform. And to run it, they simply type Java space hello, and that gives you your output. Now, I'm going to show you how to create the Hello World program. This is our first project for this week. A lot of people kind of roll their eyes when you got the Hello World program, but the Hello World program accomplishes a very important task. It makes sure that your software is installed. And so if people turn in Hello World, then you know they're up and running and ready to start programming. So let's take a look at this. Okay, our steps in Netbeans. And I updated some of these so that it had the right version number here at top. I may not have got them all changed. I'm over here in Netbeans. You do a file, new project. That's what I got here. Then Java with, choose Java with Maven, Java application, and click next. So Java with Maven and Java application, and click the next button right here. Then you want to give it a meaningful name. Maven Project 31 is probably not meaningful. Hello World would be better. And I'm going to put a date on it because I'm sure I already got a Hello World out there. Is that what it says? No, okay. Hello World. And then, let's see. Spring 2020. Doesn't like spaces, doesn't like weird characters. So, notice the project location here. Mine's under Documents, Netbeans. And I'm fine with that. But if you got a particular folder you want to store it at, then you need to create the folder and then put it here. You put it here by clicking your browse and choosing it. Now, I'm going to change mine just so we see it. Instead of documents, I'm going to choose the one I created this morning for my other class. Okay, let me go to this PC. Wake up here eventually. It'll be time to go home then. I'm looking for temp 3. Did I not create a temp 3? There it is. Spring. Boy. Spring.html. Then click finish. Oops, open. Okay, so put that project location there. And then I'll click finish. Now this creates an empty project, so there's nothing in it once it gets created. So over here under the projects window, if I expand Hello World Spring 2021, you see there's different folders over here. If I expand source packages, you see Cali.Hello World Spring 2021. That refers to a package. And we'll talk more about packages later on in the course, but for now you can think of it as a way of grouping together similar code. Now we need to create a file underneath that. And Java's got a unique name for it. And projects window, right click on source packages, choose new Java class. So new Java class. So over here, source packages. Source packages. Actually, I could right click on this and choose new Java class, and it'd be underneath that package. It doesn't have to be under that package to run, in case you're wondering. And here we want to give it a class name. And I'm just going to leave it as new class for now. And click finish. And that was this right here. Now it puts this up here at the top. These are comments. This is where you can document what your program is doing. The beginning of the comment is a slash asterisk. The closing is the asterisk slash. These right here, the asterisks there. See how they still look like they're grayed out, like they're comments? Those asterisks aren't necessary. The beginnings, the slash and the asterisk, and then the asterisk slash, the closing is what's in the middle is your comments. So I could write this program. Print hello world. Now I wish it would put it on here, but it doesn't. See, it says public class, new class. We're going to take look later on about what is a class, but you can think of it as just a program for now. It's much more than that, but you can think of it as a program. This new class right here matches the name of what our class is called. If you change this, it probably will break it, and you won't be able to run your program. So don't touch that at all. Now coming down to this next line here, this blank line, we want to type public static void main. Then we have our beginning parentheses, and then the string args. And then beginning curly brace and the closing curly brace is put there by Netbeans. So exactly as you see it here. Now this name could be whatever you call it, with no spaces, and there's some other criteria, but this next line should be exactly that. Just generally, the public refers to what's public. If you think about information that's maybe confidential to you, if I come up to you and ask you what social security number is and address, home address, you're probably not going to give me that information. That's private to you. If I ask you what your name is, well, that's for most people, I probably consider that as public. They'd tell you, well, my name's David. Static is deals with objects, which are classes. So we'll talk more about later. Void means nothing is returned. The main is our code that runs. That's what it looks like. How does it know what to run? Well, it looks for main. And then we got string, beginning bracket, closing bracket, args. We'll see this later on, but this is where you're passing in parameters into your program. System dot. Now see how it pops up with this. This will throw you at first as these windows keep popping up, but if you don't have a memory and you can't remember what the next part is, then it pops up there and you can do a enter and then dot and choose whichever one. And then in here, I'll put the hello world like that. Okay. Now if I run this is an important thing to note here. Here's the run. But if I try to run it, comes up and tells us available main classes, no main classes found. You'll do this a lot when you're starting a new program. You're sitting there, well, why can't I choose it? It's right there. I wrote my code. We're going to cancel here. Notice up here the two icon, or this icon with the two diskettes. If I click it, that saves all my files. And now if I run that, now you see that there's a main class there. It's already highlighted, so I just say select main class. On a bunch of other displays, it tells us hello world. Questions on the hello world? Okay, let's change this to just an S. Now when I take my mouse off, see how it puts a red squiggly under there? And then if I tried running it, maybe, okay, good. Now I'm running it twice. Build failure. So it didn't like something. Java is case sensitive. Lowercase s versus uppercase s are two different things. That should be an uppercase s there. So look for those red squigglies. Those red squigglies indicate you got an error of some sort. So you can correct it before you run it. Because running it, you see, didn't really give me a whole lot of information. Sometimes it does, sometimes it doesn't. Okay, so this is the first project. You've gone through, you've recreated this. You ran it to make sure that Java's installed correctly on your computer. I want to save it. And then I'm going to do a file, and then I'm looking right at it. Close all projects, I guess. I don't see a closed project. That'll close the project. So let's see how to turn that in then. If I go back to my File Explorer here and go to C drive, go to my folder. There it is, spring.html. You see there's a folder that says Hello World. This one right here. If I double click into it, you see it has lots of different files. I start clicking in there. There's just one there, I guess. Okay, I'm going to go back to this Hello World, or no, Spring HTML. You want to go back to the main folder where you put your projects, and this is the one we want to turn in. So we're going to right click on it, and we'll say send to compressed zip folder. And then you just simply press enter. This right here, this zip file is the one you want to upload. So a lot of people make that mistake in the CIS courses, is they'll upload the wrong file. So make sure you zip it up, and that's when you want to upload. Okay, now let's create a different, and this will be the second project, is we're going to do math operations. Specifically, I'm going to do the addition part, and then for the project, I'm going to have you do subtraction, multiplication, and division. Grab a drink here. Now, part of programming is such that you think about how you do it in real life, and that's oftentimes how you'll program it. For example, if I wanted to have somebody add two numbers for me, I would go up to them and I'd say, or I would add two numbers for somebody else. I'd go up to them and I'd say, what's your first number? They'd tell me 3. Now I'd say, what's your second number? They'd tell me 4. Now those two numbers, I've just stored up in my brain. They're stored in brain cells. And so then I get ready to calculate them. I think, okay, what's 3 plus 4? It's 7. So I've done my calculation, and then I need to return the result back to the user. So I say, hey, the sum is 7. The same way you did that from your individual day-to-day side is how you do in the program. A lot of people think that it's something unique you're doing with programming, but it's just simulating real life. Okay, so let's create a new project. I'll do a file, new project. Java with Maven, Java application, next. And here I'm going to call it math operations. I'm still in my same project location, so that's good. Click finish. Give them meaningful names. So later on, when you come back in and you're trying to find which program is math operations, and you can find it. Now here are the source packages. If I expand this, then you got this Kali.math operations. This is again a package. I'm going to right click on that, choose new in Java class. Okay. And I'm going to call this calculations. Notice the name here matches the name of the file, calculations.java. I want to highlight and get rid of the comments there. Notice the package says Kali.math operations, and that's over here under Kali.math operations. Now, I want to bring in code. I want to do an import. Got over all that. Okay, so let's come down to here. Notice this import java.util.scanner. Important part is remembering to import Java. Import Java dot. Now, when you do a dot, see how this pops up? And so, if you can't remember where it's at and so forth, this will help you. It's under utilities what we're wanting. So, if I do my dot, type util dot. These are all the different pieces we can bring in. Now, when I say pieces, these are bits of code for the most part, and somebody else has written has got working for us, so we don't have to reinvent the wheel. Example of that: I'll probably go home this afternoon, watch TV, relax a little bit. I'll use remote, and the remote is already built for me. All I have to do is push the buttons. Code. These libraries we're bringing in is already written for us. All we have to do is not push buttons, but pass some parameters. So same principle. When I go home, I'm not going to have to build a remote from scratch. Boy, that'd be hideous. Every time I wanted to use the TV, I'd have to build a remote from scratch. I'd never watch TV. It'd take me a month to get the remote built. Assuming I could. So again, this is just code somebody else has written that we're going to bring in. Particularly, we want to bring in something called a scanner. So for java.util.scanner. So do a backspace and put another dot and scanner, semicolon. So you end the line with a semicolon. So when this runs, this is going to bring in all the code that somebody's written that does scanning. Okay, so we come down to the calculations here. This is the part I can never remember. I can remember most things in Java. I need to put this on a wall or something. Public static void main. Okay, so public static void main and all what is it? String args. Constantly, I'll make this mistake. When I write a Java program, I will not put that line of code there. I did that this morning. I was coming up with this that I could put into the PowerPoint so you could have it readily accessible, and my program was running. It's like, what's wrong? This is such a basic program. Well, what was wrong is I forgot this right here. In general, in programming, if you have a beginning curly brace, you'll have a closing curly brace. If you have a beginning brace, you'll have a closing curly brace. You can line them up however you want. A popular convention is to put the beginning brace at the end of the line like that, and then have the closing right here. Another way you can do it is have the beginning on a separate line and have it line up with the closing one. Now, you need to develop some kind of standards for your programming. If you follow those standards, it's easier to read. You know, spacing, your braces, and so forth. Now I'm going to declare num1, num2, and sum. So I know some of you have heard this. If you've had me in other classes, you probably get tired of hearing me repeat, but it is an important concept for every programming class. My son was born June 29th. Wife was born June 16th, June 9th, something like that. And I was married in September. those pieces of information I remember are stored in brain cells. And then if I want to retrieve them, then whatever goes out and gets them and brings them back. Well, the brain cells of a computer program are called variables. And that's what we're doing here. The INT means that we're saying that these are going to be numbers, specifically numbers with no decimals. And I'm going to have three variables, num1, num2, and sum. This is like those three pieces of information I just said that I remember in my head. I got three pieces of information set aside. I still can remember the 3 and 4 I input just a little bit ago in the previous class, the same one I gave you an example on. So again, our memory remembers that information. Probably next week, if you ask me those two numbers, I won't be able to say what they are. And again, that ends with semicolon. Now you can have them on the same line like that. That's fine. You can also have them on separate lines like this. Your choice. It's probably easier to put them all on one line, but now we need to ask the user for the first number. So I'll say system.out. Wait a minute, I need to create my scanner. Scanner my in equals new scanner system.in. And I got this all in the PowerPoint here. The my in might be the only thing that's different. No, it's the same. Just like these were integers, numbers with no decimals, this scanner is referring to a particular object, and I call it my in. And this is what's going to allow me to get input from the user. Now this my in, you can call it whatever you want. And then equals new scanner system in. This has to always be the same. It never changes. So if you're wondering how to declare a scanner, well, you do it that way. Just my in should be whatever name you're trying to find. So now that I got that declared, then I'm going to prompt them. So I say system.out.println and input number 1. Then num1 is equal to my in. Now where that's coming from is this right here. So that's going to call my scanner and allows me to get a number or whatever. So my in dot. You notice there's one down here that says next int. And down here it tells you what that is. It says scans next to open input as an integer. Invocation of this method of this form behaves exactly the same way as the invocation. So it gives you a lot of different information there. Okay. So I said next int. Over here on my instructions. So what that's going to do is it's going to get the next integer. So it's waiting for a number, waiting for you to put in 3. And press enter. Now I need to prompt for the second number. System.out.println. And I'll say input number 2. Now I'll say num2 is equal to my in dot next int. This gets the next number from the user. Maybe I put 4 in and press enter. Now at this point, I got my two numbers in. I want to add them together. So sum is equal to num1 plus num2. Again, notice how these lines are ending with semicolon. There are going to be a couple exceptions to that, but for the most part, all of your lines of code in Java should have semicolons up. That'll change when you get to if else, the while, and the for. You have to handle those differently. Okay, so I've asked the person for the number, they gave it to me. I asked them for the second number, they gave it to me. I added them in my head. Now I got to tell the person what the answer is. And in terms of our program, we'll print it out to the screen. System.out, print line, and then I can print sum. Now let's save this and then run it. Remember, if you don't save it, then it doesn't know what your main class is. So that's selected, and I'll click select main class. I notice it's coming up and asking us for input number 1. If I start typing a number now, it's going to type it up here in the code. So like if I type 3, it'll put it up there. If I want to pass it in as a parameter of the program, down here I want to click in this window so my cursor's there and I type in 3. Now if I press enter, it'll come up and ask me for my second number. I put in 4 and then I press enter. That gives us 7. Now that doesn't look very nice. It doesn't tell me what that is and so forth. So what we can do, the system.out.println. So you can this in theory goes down to the next line. The out we're right into the screen, and so this is what prints it. Now, if I want to print something a lot more fancy, then I'll do a printf. That's referred to as print formatted. I'm going to say the sum is %d/n, and then comma sum. What is this? Well, when you got quotes around it, that's a string. String can be alphanumeric, can be whatever. And I say the sum is, and then I got %d. What that percent does is a wild card for the program. Is hey, there's a variable or something that follows the parentheses here. So it'll take the value of sum and plug it in for the %d. Now the /n goes to the next line. So now let's run it. Always forget to resize this. Coming up and ask me for input number 1. I'll click down here. I'll type 7 and then 8. And it tells me my sum is 15. So 7 plus 8 does give us 15. Now the what I'm going to have you do for the second project on this is I want you to expand upon this. I want you to add in the difference, the multiplication, and division. Now multiplication is done with an asterisk. I'm going to add one more in here just so you see how would you modify this. Well, up here I got sum. So put a comma and I'll write difference like that. Down here where I'm calculating the sum, I'm going to do an enter on that, and I'll do difference is equal to num1 minus num2. And then we want to print out the result. So on the next line, I'm going to say system.out.println, or printf, sorry. The difference is %d/n, quotes, comma, sum. Sum. So again, difference. When I do that and run it, click down here, I put 7 in, then 8. 7 plus 8 is 15. 7 minus 8 does give us -1. So again, when you go through this, you just recreate exactly as you saw me do it, and then change, add another value instead of difference. You want a product or you want a quotient, then you just add that in. Questions, any of that? Okay, so let's talk about just some miscellaneous topics in Java. Java programs are made up of class and method definitions. Methods are made up of statements. Statement is a line of code that performs a basic operation, just like adding two numbers together or subtracting it. Java is case sensitive, which means that uppercase and lowercase are not the same, and I demonstrated that. Class is a collection of methods. We haven't really gotten into that yet, but this program defines a class named hello. You can give a class any name you like, but it's conventional to start with a capital letter. Notice that this is calculations. Don't see no uppercase letter here. That's fine. Like I said, you can call it whatever you want for the most part. People have different conventions for it. It just drives you crazy. Some people have a camel back, camel hump methodology for naming. So if I was trying to name, for example, the mountain fell, then I'd have the mountain fell. That'd be the name of my variable. It starts with lowercase, and then your first letter that's the letter of another word, you make uppercase. So that's why M for mountain is uppercase. Now my next one is fell, and so you see the uppercase there. And if you kind of envision it, a camel, you got a hump there, you got another hump there. Although you can have more than just two, but that's the idea. Java uses squiggly braces to group things together. We talked about that. We did not talk about the two slashes. It's comment. So up here, if I didn't want all this comment, but I did want to put something there, hello world program. David Hayes. So I like slashes. The two slashes better, and that's what I'll usually use if I use anything. The other one is nice, very nice, though I just have to refresh my memory on it. Reason why it's nice, well, if I want to comment out some code so it doesn't run, you put slash and then the asterisk, and then you come down here after your last line and you do asterisk slash. So now it will not run this code. This is handy if you try to figure out a problem, but that part of the code imports in 10,000 records. You don't want to keep running it over and over, importing 10,000 records over and over, because you have to clean it up. So you can comment out code like that. Do Control Z to get rid of that. There we go. Phrases appear in quotation marks are called strings because they contain a sequence of characters strung together. System.out print line appends a special character called a new line that moves to the beginning of the next line. If you don't want a new line at the end, you can use print instead of print line. Now here, I didn't really talk about this because I want to talk about it with these escape sequences in here and everything. The sum is, so forth. You have to have quotes around that first part. And then I say the sum is percent %D. A percent is a wild card. And specifically, a percent %D says, hey, we're going to have an integer. If you're wondering why isn't it I for integer, the D stands for decimal integer, which doesn't make sense to me because integer means there is no decimals. But that's the way it works. The slash in you see right here. This tells us to go down to the next line. You see here the slash in says new line. If I wanted to go down one more line, I put another slash in. And now if I run that, click down here, 7, 8. Oh, okay, I see it. I was looking for 2 lines. I was looking in the wrong place. So one line would go down to here, another line goes down to here. If you want to do a tab, horizontal tab, you do a slash T. If you want a double quote, you have to do a slash double quote. You can't put a double quote inside of a double quote because it messes it up in a string. And then if you want a backslash, you do a slash slash, and that'll give you your backslash. And there's our program we just wrote. Now, we're done with the material for this week. Is there any questions, anything? Yeah, websites, apps. There's a package called Android Studio that's used to develop apps for your smartphone, the Android smartphone, and it uses Java as its language. It might take too long to come up. But yeah, if you want to develop programs for your smartphone or for a tablet, then Java would do that. It's used, like you say, for web applications. So something that's running on the web can have Java. And if you want to program on your network that's not on the web, but everybody can run, then Java's a good choice. Java is probably the most popular language in terms of, or not, maybe not popular, the most in demand language that people are looking for. If I come back to dice.com, this is the website for IT jobs. If I just do a search with nothing, then you'll see 57,557 jobs. That's how many's out there currently. If I look at the ones that have been posted in the last 7 days, 47,130. So about 6,000, almost 7,000 jobs are being posted per day in IT. Now, if I come here and type in Java, you see there's 9,714 jobs. So a huge amount of them want Java. If I type in C++, you see it's half the number of jobs. Now, Java is the one that has been number one for a long time. COBOL, what I used to program in the 80s. 204 jobs, mainframe. So those jobs kind of going away. That kind of gives you an idea of the number of people who use it and so forth. Just Java seems like it's being used more and more in development. Here's this finally came up. This right here is Java for running an app, and specifically notice how it's declaring a variable int. This one has year, month, day, hour, and minute. So, what other questions? We'll very quickly go away from this console like this, and we'll be developing graphical ones, kind of like you see right here. Um, so yeah, you develop the entire interface within Java. Now, yeah, because console's pretty dry and boring. You never give somebody this. Um, but yeah, it's a wonderful package. We'll probably next class, if I had to guess, we'll look at the GUI side. I don't like the side. Nobody would program, and you can actually write it completely in Java like a Notepad. But we're going to use this to build our interface because it's so much easier. You're welcome. Well, unless there's any other questions, have a good day and weekend. And if you have trouble with this, I'll be posting probably tomorrow when I'm be available for jumping on Zoom to help you. And what you basically do is you share your screen, and I kind of guide you, say, here's what you're doing wrong. That should be, maybe you'll have this, and I'll say that should be a capital S. So, but anyway, have a good weekend.